Hello everyone. Today we are going to cover lesson 1 of chapter 1, that is measurement. Here is the contact information. If you face any difficulty or any query regarding this lesson, you can contact. Learning objective of this lesson is that you will be able to know about the statement of physics. You show understanding that all physical quantities consist of numerical magnitude and a unit. You will be able to list the 7 base quantities and their SI units. Learners will be able to use prefixes and symbols to indicate very large or very small SI quantities. So to cover those objectives, here is the content that what we are going to cover in this lesson. What is physics? Physical quantities and SI units, prefixes of SI for SI units, standard form of expressing physical quantities. So let's see what is physics. Physics is the branch of science which is concerned with the nature and properties of matter and energy. In other words, we sometimes see this statement also that physics is the study of our natural world or natural phenomena. So what is natural world? That we say that physics is the study of our natural world, then what is natural world? Everything which is surrounding us is natural world, from very large to very small. For example, solar system, very large. And for example, atom, very small. Here is the solar system. You see that planets are revolving in the orbits around solar system. When we study about these planets, we are basically studying about physics. Similarly, when we talk about such things which are surrounding us, for example, table is surrounding us. When we study about the dimensions of the table, we are basically studying about physics. So natural phenomena are formation of rainbow. Sometimes when we see that rainbow is formed, how that rainbow is formed, when we talk about that, we basically are studying physics. Falling of the things from top to bottom or up to down, and many more such examples are representing that we are studying physics. Things mostly drop down. When we leave the objects, it what happens, they come towards downside. Why they fall down? When we study about those things, we are talking about physics. So here in first statement we were saying that which is concerned with nature. We have covered this thing, that how physics is concerned with nature. And we say properties of matter, how properties of matter the physics is concerned. What is matter? Matter is any substance that has mass and occupies space. When we talk about such objects, such substances, we basically also cover their properties. So it is also a physics. And energy is also required to change the state or to change the scenario. To make the objects move, we need energy. So in physics, energy is a property of matter. Such study is also called knowledge of nature. See here one example related to matter and energy. Here I have a car. It has some mass. It is occupying some space. It is a matter. And to move this car so that State is changed from rest to motion. I need some energy. So this is all about physics. Physics is further divided into major topics such as general physics, thermal physics, light, waves and sound, electricity and magnetism. All these topics are related to two main ideas, that is matter and energy. These topics which we have further divided, they are basically related to two main ideas, either to matter, either to energy. So here are some branches of physics also mentioned in the picture. Now we will talk about our second objective, that is physical quantities and SI units. Before going into the statement of physical quantities, let's discuss one example. When you are traveling, you might have seen that at the side of the road, signboards are placed, which tell us information about the distance from for the upcoming city or distance from one city to another. If you see this, here is one a picture in which car is at this location. Suppose you are sitting in this car. From this location, you see one signboard at the side of the road. If you see this signboard, what is here? City A is 2 kilometers far. City B distance is 78 kilometers. City C distance is 99 kilometers. From this location, when you are seeing this signboard, the distance of city A is basically from this point onwards is 2 kilometers. City B distance is 78 kilometers from this location, not from city A onwards, from this location. So this 2 is basically a numerical value. This kilometer is SI unit, or you can say a unit, not SI unit. SI unit for distance is meter. So you can say that this is a unit. So let's see one. For example, here is one example. Distance from city A to city B is 76 kilometer. It is talking about the distance from city A to city B, not from this location. When this car will reach at city A, from that city onwards till city B or to city B, you will be having how much distance in between? 76 kilometers. So physical quantity is a quantity that can be measured. Distance can be measured. For city A to B, distance can be measured. In above example, distance is a physical quantity because it consists of numerical magnitude, that is 76. If you see here, this is a numerical magnitude, and a unit, that is kilometer. So a physical quantity consists of two things, numerical magnitude and a unit. So here are some examples which are physical quantities: length, mass, time, area. If we talk about this example, time, when we measure time, we have physical quantity and unit. For example, 2 seconds, 3 seconds, 1 hour. 1 is basically representing to numerical magnitude and the hour is unit. Physical quantities are further categorized into two, that are base quantities and derived quantities. So let's talk about base quantities. Base quantities are those quantities on the basis of which other quantities can be expressed. Sometimes we say that this is the base of something, means that something is dependent on base. So some quantities which are based on base quantities or based on such quantities from where further quantities can be derived, they are base quantities. So base quantities are 7, which are listed here in the table. Mostly we will see first 5 in our this syllabus. Base quantity length, or you can say width or height. SI unit for this is meter. Symbol for SI unit is M. Similarly, time, SI unit is SI unit is second. Symbol for second is S. Mass is given, temperature is given, and so many other base quantities are given. Now move towards base derived quantities. Now we are going to discuss about derived quantities. Derived quantities are those quantities that are derived from the base quantities. As we were previously saying that base quantities are those on the base of which we can express other quantities. So derived quantities can be expressed from the base quantities. In other words, you can say quantities that are calculated from two or more measurements. Area. You cannot measure area. You can calculate area. Similarly, volume, speed, and density. For example, speed is derived from length, that is distance, and time. Speed is equal to distance over time. If you have measured distance and you have calculated time, you can calculate speed. Similarly, if you have measured the length and width, you can calculate area. Such quantities are derived quantities. Now we will talk about SI units. That why do we need SI units? Units are very important, and most of the time students miss to write units. So be careful regarding units. Units are very important. SI unit is an international system of measurements that are used universally in technical and scientific research to avoid the confusion with the units. It was not until 1968 then scientists agreed to adopt one universal set of units, the SI units. Before 1968, people used to measure some lengths or used measurements by span, by foot. So it was not a standard unit. Having a standard unit system is important because it helps the entire world to understand the measurement in one set of unit system. If we are not following one set of unit system for the measurement, then there will be a confusion. To avoid the confusion, we adopted SI unit system. Because sometimes what happened before 1968, people, for example, one person measured the length of the table and he said that he measured 5 spans. But one more person measured the length of the same table, but he says that there is some difference. It is not 5 span. So to avoid such confusions, we adopted this international system, and we have adopted means one set of unit system. So it is very important so that entire world will be easy to understand about the measurement of objects. So follow SI unit and never forget to write the units with physical quantities. So now we are going to talk about prefixes for SI units. Prefixes are the words or letters which we add to the beginning of a word to make a new word. In simple words, if I say to make a new word, we add some letters before that word becomes new word and it is a prefix. For example, the word unhappy. Here, happy is one word and we have included two letters, that is un, u and n, and it becomes unhappy. Un consists of the makes this a new word and it is a prefix. The word unhappy consists of prefix that is un, which means not, combined with the word happy. Similarly, we use prefixes for SI units. Sometimes with SI units, we add some letters. When we add some letters with SI units, it becomes prefix. Prefixes are useful for expressing physical quantities that are either very big or very small. So here are some examples. If you see here, it is 0.00000 and 0.01 meter. This is very shortest distance, very small distance. So to write, if in some problem you have to write this value so many times, then it will be very difficult for you to write this again and again so much digits. So to express this like this, 0.1 micrometer, this micro is a prefix where micro represents the submultiple of 10 raised to power minus 6. This micro is changing these 6 zeros into submultiple of this number. So this is a prefix. We have written this very small value into the prefix form. So if we have a very largest value, that is 15,000 meter, it is a very largest distance, it can be expressed as 15 kilometer, where k represents the multiple, that is 10 power 3. These three zeros are changing into 10 power 3. So it will be 15 kilometer. K is representing here a prefix. Instead of using decimal notations, it is more convenient to use prefixes to represent the quantity. For example, if we have one value, this value, if we need to mention this quantity a number of times, it would be cumbersome to use this type of notation. It will be difficult for us. So it's better we write above mentioned value as this, as we discussed in previous slide. It would be more convenient to write it multiple times. In one problem, if we want to write this value again and again, so why not we go for such format? In upcoming slide, we have some commonly used prefixes. Here is the table. You can see this table from your book as well. See here, kilo is here. This is a prefix. Its symbol is given here. Similarly, centi, milli, micro, deca, hecto, mega, giga. So you have to learn these prefixes. Now we will talk about standard form. Scientific notation is a way to write large or small numbers with some power of 10. When we write large or small numbers with some power of 10, it becomes a standard form. Standard form is another convenient and acceptable way of expressing physical quantities. If you recall that in previous slides we were discussing about prefixes, and in prefixes we include an additional letter with SI unit. But this time, instead of including or changing unit, we have to express physical quantity with some power of 10. For example, a number 27750 can be expressed as 27.758 into 10 power 3. How this 10 power 3 came? Suppose when we are not given any decimal in such values, we suppose that decimal is here. It is shifted towards left, one digit, second digit, and third digit. So decimal is here. We moved 3 digits, so we are including 10 raised to power 3. If we move 4 digits, then it will be 2.7750 into 10's power 3. Here is one, 10's power 4. Here is one example in which we have moved 4 digits and then it becomes 6.275 into 10's power 4. All these are correct, but the number that has one non-zero digit before the decimal, example this one, 6.275 into 10 power 4, will be more preferable standard form. Means to say that on the left hand side, after decimal, on the left hand side or before decimal, we must have one non-zero digit. Then it will be a more preferable standard form. Similarly, the standard form for this will be 0.45 into 10's power minus 3 second, or if you follow this, that one non-zero digit should be before decimal, then it will be 4.5 second into 10's power minus 4 second. What happened that we have shifted this decimal towards right, one digit, second, third, and fourth digit. 4 digit we have moved, so it is 10's power minus 4. When we are moving from left to right, we include minus with the power. And when we are moving from right to left, we keep it as positive. We keep this power as positive. So this is about standard form. Scientific notation has number of useful properties and is commonly used in calculators. You might have seen while doing some calculation in calculators that such standard forms also appear during the calculation. And it is used in calculators by scientists, mathematicians, and engineers. So here are some quantities taken from book, and here is the uh, title, and you can say edition is also mentioned, authors names are also mentioned here, so from where this some quantities are taken. Here the questions are given to you. Solve the below mentioned examples and drop your answers as comments, or you can share your answers or these questions, solved questions with me on my contact information. So here is one example. Express 3 megajoules 3 megajoules in standard form. In standard form, it can be expressed as 3 into 10's power 6. Why 10's power 6? Because mega is equal to 10 power 6. The factor of mega is 10 power 6. That's why in standard form it will be in this way. So that's for today's lesson, and here is the conclusion that we talk about physics. Here's the conclusion that we talk about the physics, physical quantities, base quantities, derived quantities, prefixes, and standard form. Do not forget to hit the like button. Thank you so much.